All right, in 9-0 notes, we're going to go back and do a bunch of triangle review because we've got to have this stuff down, guys. That triangle stuff is not going away for the entire year, okay? So let's go back and make sure that we've got this down. Go ahead and write those directions down for yourself. Remember the directions we've done over and over. Always give exact answers when possible, right? So if it's possible, I expect like √3, not a rounded decimal, okay? So exact answers when possible. If it's not, it's going to say otherwise round answers to the nearest hundredth. That's what we're going to do. I know you guys don't necessarily have a bunch of different colored pencils or pens, so I'm going to try to stay in the habit of just circling what I am giving you versus the work. So on this right triangle, let's say I'm giving you 14 for that length, 50 for that length, and I want you to find x. Okay. Remember our old stuff, guys. I have 2 out of 3 sides given to me. So the first thing we do, reducing, triples, Pythagorean theorem. Okay, that's what I should be thinking. So if I reduce by 2, I would get 7 and 25. I should recognize that as a triple. Okay, 7, 24, 25 is the triple. That means I should automatically know this side is 24. Remember to undo what we did at the start. You would have to multiply by 2, and the true x that we want, the purple one, would actually be a length of 48. Okay, next problem. Let's give you x we want to find here, 17-degree angle here, and this side is 40. Okay, so if that's all the information that's given to me, again, I'm analyzing what I have. I notice that that is 1 angle and 2 sides. Okay, 1 angle and 2 sides. 1 angle and 2 sides is supposed to be your tip-off that it is trig. Okay, remember from the angle's perspective is the key. From this angle's perspective, you have the adjacent side and the hypotenuse side. That means adjacent and hypotenuse, remember, is part of ka from SOHCAHTOA. So that should tell you that this is cosine of the angle equals the adjacent side over the hypotenuse side. Remember, if you're solving for sides, what do? We make everything a fraction. Just going to make that look a little bit better. Make everything a fraction, cross multiply and solve. So by that I mean, I'm going to put that over 1. Cross multiply and solve. Remember, you've got to show me the exact answer first. The exact answer would be x equals 40 cosine 17 degrees. If you're more comfortable putting the cosine of 17 in parentheses, go for it. But technically, you don't need it. That's your exact answer that I expect to see before you type in your calculator to get, now this is going to be rounded to the nearest hundredth, we should get 38.25. It's a side, so it's a length, no degrees. There we go. Okay. All right, next right triangle. Let's give you x here to solve for, y here to solve for, and 10 for this length, and 30 degrees for this angle. All right, so for this problem, you should be thinking back to, all right, the first thing I always check are my special right triangles. I check 30, 60, 90, 45, 45, 90 first. I do see that this is a 30, 60, 90, right? This one would be 60. And therefore, all I need is one side. So the 10 is perfect. If I've got the hypotenuse, I have to find the short leg first by dividing by 2. So y equals 5 would be my final answer for that side. And then I take the short side. How do I get to the long leg? Short leg to long leg. I want to get longer, so I should multiply by √3. So you would get 5√3 for our answer for x. Okay. All right, next one. Let's give you x, 5, and 9. So again, analyzing what I have, this is 2 out of 3 sides of a triangle. 2 out of 3 sides of a triangle that's not a special right triangle means reduce triples and Pythagorean theorem to me. I notice 5 and 9 don't reduce. Is there a triple with 5 and 9? Nope. So I'm stuck back with Pythagorean theorem. Right? So x squared plus 5 squared equals 9 squared. Do the numbers with me. 25, 81. So if I subtract 25, x squared would equal 56. I need to find x, which is root 56. I've got to break that down, simplify it as much as possible. Perfect squares, factor tree, whatever it is, okay, that works for you. Maybe if we do factor tree this time, I notice 2 goes into that, so it would be root 2 times root 28. 28's even, so I might do 2 again. Root 2 times root 14. Root 2 times root 7. 7's prime, doesn't break down any further. So remember, you just turned the square root of 56 into the square root of 2 times 2 times 2 times 7. Everything at the end of the branches. Okay, so however you need to write that for yourself. If you need the extra step to see that this is 2 times 2 times 2 times 7 under the root, go for it. Okay, remember they come out in pairs. So that pair means 1 will come out, 1 will go away, right? And you're left with a 2 and the 7 that can't come out. So you're left with x equaling 2 root 14. Now, why do you get a 2 out front? Because the 2 times 2 is 4, and the square root of 4 that we circled in red is 2. Okay? So there's your final answer. However, you need to review that stuff for yourself. All right, next picture. Let's go with x, 50, and 26 degrees. Analyze what's given in the picture. One angle and 2 sides is your tip-off that it is trig. Why don't you stop the video and go ahead and try to do that for yourself, and then come back and join me. All right, so again, trig is from the angle's perspective. So I have the opposite side and the adjacent side. O and A means to me kind of like the sine, cosine, tangent, right? So the SOHCAHTOA that we did above. Sorry, try to be consistent. Sorry, we have the opposite and the adjacent. Opposite and the adjacent, and so that would be part of SOHCAHTOA, right? So that's part of tangent. So we're saying tangent of the angle, you should already have this filled in, equals the opposite of side of 50 over the adjacent side of 50. We said if you're doing sides, you're making them a fraction by putting that over 1, cross multiplying. So you would have x times the tangent of 26 degrees equals 50. And you want x by itself, so you need to divide by that tangent of 26. So here's the exact answer that I expect to see from you before you type into your calculator to get to the nearest hundredth, 102.52. Okay, 102.52. All right, next one. Let's give you 5, 12, and x here. Again, analyzing what's given to you in the problem. That is one angle and 2 sides again. That is your tip-off again that it is trig. Okay. From this angle's perspective, I have opposite and hypotenuse. So again, opposite and hypotenuse is part of SOHCAHTOA. So that's telling me sine of the angle equals the opposite side over the hypotenuse side. Difference this time, how do we solve for an angle? When you're solving for an angle, you use the arc key. So you need to know to tell me that x equals arc or inverse sine, but arc sine of 5/12. There's the exact answer I expect to see from you before you type it in your calculator. Rounded to the nearest hundredth would give us 24.62 degrees. This is an angle. You must have degrees. Okay. All right. Let's do a couple more. See where we are. Let's get us a little more room. For this one, let's mark those two. Put x here. 2√3 here. And y here. All right, well, based on 3 sides, I know I'm supposed to look for 30, 60, 90, 45, 45, 90, and then do reducing triples Pythagorean theorem. Okay, in order. I claim this is a special right triangle. I see 2 legs marked the same. That to me means this is 45, 45, 90. Okay, so the easiest thing is the other leg, right? Y has to also equal 2√3. All right, in a 45, 45, 90, how do you go to the hypotenuse? You want to get longer, therefore you're going to multiply by something. So I'll just say you're going to take 2√3 and you're going to multiply by something, and that number is √2. Okay, that should give us x equals 2√6. Okay, the 2 and the 1 in front of the root multiply, the 3 and the 2 under the root multiply. Okay. All right, now last one here, guys. Let's give you y here, x here, 18 here. Fix that a little bit. 18 here, and 45 degrees there. Okay, so again, I see that I've got 3 sides, okay, that I'm kind of looking for or have part of, and I've got a 45. Well, guys, isn't this also a 45, 45, 90? Okay, so how do I go from hypotenuse to legs? I want to get shorter, and therefore I should be taking 18, we'll just do our work down here, and dividing by √2. Okay, you either need to know how to do your shortcut, which we'll talk about in a minute, or you got to rationalize. Remember, you can't leave roots in a denominator. You rationalize by multiplying by that same number on the top and the bottom, because that's the same as multiplying by 1. You can't change the problem. Multiplying straight across, we would get 18 √2 over 2. And 18 over 2 reduces to 9, and you still have the √2. Okay? So that means x equals 9√2. Okay? In this picture. Now, notice in a 45, 45, 90, the legs are equal, right? So you should also know that y equals 9√2. Now let's talk about like our real shortcut, like when we were talking about like mad minutes and stuff also. If you want to be super fast. Isn't the pattern we discovered, guys, is that you take this hypotenuse, cut that number in half, and multiply it by √2. It's a little bit faster to recognize, but you got to get it right every single time. So I'd rather have you rationalize if you're going to forget that. Okay? All right, get everything down that you need to, all of your questions answered once and for all about right triangles, because you're going to keep using that stuff over and over. All right, good luck.